It all starts with one idea. Have you ever wondered how today's top CEOs, business leaders, and people who work for the most innovative companies in the world found success? Join host George Davison as he explores the innovators that are shaping tomorrow's world today.
Today we have John Halvorson, who is the Director of Marketing for SMC. They're a company that does pneumatics and a lot of other advanced technology out there. But I like to think of them as a robot maker as well. Good morning, John.
Hey, good morning, George. Thanks for having me.
It's great to have you here today. Well, I'm hoping that today we can help our audience take a look into the future a little bit as to where the jobs of the future are, and if we can explain a little bit about how you got to where you are in your career. Maybe we can shed some light on how things come to be.
Sounds good.
All right. Well, can you tell me a little bit about how SMC was actually founded?
Yeah, absolutely. SMC was started in 1959 in Japan. Making the first product that they manufactured was sintered metal elements for industrial filters out of a garage, just a really small location. And over the next dozen years, SMC started manufacturing other components for industrial automation, including solenoid valves, pneumatic actuators, and air preparation equipment, so filters, regulators, lubricators to prepare the compressed air, which is pneumatics is the use of compressed air. Mm-hmm. And since that time, I guess in 1977, SMC started their U.S. subsidiary, SMC Corporation of America. I wasn't there at that time. That was a while ago.
I would hope not.
Right? And since then, we're now the world's largest supplier of pneumatic components for industrial automation, as well as we offer a lot of other products for industrial automation and process automation.
Interesting. So for the audience, let's kind of walk it back a little bit and kind of break this into two pieces. Okay. If we could know a little more about your founder and what was the cause, if you know back when, what caused the founder to actually create the organization? That would be the first part of the question. And then can we talk a little more about describing how pneumatics works and why it works the way it does?
Right. So those are great questions. Our founder, Mr. Takada, was really looking for what customers needed. That's really been the driving principle of the company ever since it started, is listening to customers in the industrial automation space and finding out, do you have a problem? We can help you we can help you fix that, and we can try to create a unique solution that really helps customers to become more efficient and to lower their operating costs or lower their production costs.
So in a way, he was using his observational skills and his listening skills and going out to an audience and inquiring what are their needs so that he could figure out a way to maybe help fulfill those needs, and that created an opportunity. Is that fair?
That's a perfect assessment of it. Yes, if there's a need, let's really understand that need from a lot of different angles, and then let's develop a product that's going to fit that need, so that and then there's the whole everything after all the work that comes after that. But having that idea and a need from a customer is really the first step. Wonderful.
So that's great for the audience to understand. When you're starting out in the world, it's trying to understand how to figure out your way in life and what you may be interested in doing with your career. So it seems as though he figured out that he wanted to solve some problems for companies.
That's right.
Okay. And then so he became somewhat of an expert in the world of pneumatics. And so for the audience, why don't we delve into that a little bit and try to describe it in such a way that they can really grasp what air and pressure is all about. In their own home, we see that, or even in the human body, they have a pneumatic system, don't they?
Right. So I would guess that of all your listeners, 99% of them have a pneumatic device in their garage. It's called a bike pump. So a bike pump is essentially taking air and compressing it into the bike tire. Mm-hmm. So an industrial pneumatic system works very similarly, except it's working in opposite. We're using an industrial compressor to charge the tank or the tire, and then we're releasing the air in the other direction. So for a bike pump, you're creating the force, mm-hmm. you're pumping the tire. In an industrial application, the bike pump's moving on its own. It's using the compressed air as an energy source, and then it's perhaps holding a workpiece in place in a machine. It's moving a box off a conveyor belt, so the force is not applied by the human hand. The force is applied by the bike pump itself. So it's like a bike pump in reverse.
Wonderful. So in other words, like if I'm on the Amazon production line, there's 1 million packages coming down there a day, I wouldn't want to be the human being having to push the box off the assembly line 1 million times that day.
That's exactly right. Your arm would get tired.
Right. So a pneumatic arm, an air compressor, an air compression is starting to move that lever to push the box off the line, isn't it?
That's right. Yeah, and it's without getting too deep into the math, it's force equals pressure times area. So if I have 80 pounds per square inch or 60 pounds per square inch of compressed air, and if I have a small piston, that's going to be a smaller force. If I have a big heavy box, I need a big piston. Big piston is more area. Mm-hmm. Force equals pressure times area. So a bigger area behind the piston means bigger force. Wonderful.
Hey, we just figured out that math is important.
Works. Yeah, I actually had a use for it. Turns out.
That's great stuff. Well, thanks for that. Hopefully that gets a picture going in our audience's mind as to how the world of pneumatics somewhat came about, and then how it's making an impact to make, let's say, work life better for human beings, right?
Right.
So let's talk a little bit about your position at SMC, and can you walk me back to, let's say, can you remember back when you were in high school and what was going on, and take us through some of the good, and if you can tell us a little failure or two along the way. We usually fail our way forward in life, and I think it's good for our young people to understand that that's normal.
Yeah, absolutely. So I went to high school in the Midwest, and I always knew I was on an engineering route. So I applied to several schools and was accepted to most of them, and went to school for mechanical engineering. And I was actually a mechanical engineer for 10 years, but mm-hmm. found that wasn't really the right fit for me.
Interesting.
And went back to school and got an MBA, Master's of Business Administration. And then, interestingly, ended up right back at the same company that I started. So I left engineering, which the company was SMC. I left, did some other things, got an MBA, and said I'm going to go work in business, and ended up right back at the same company that I started with, in more of a business role. So I worked in a product manager position, which is kind of in between our engineering group and our sales group. We're trying and really, if I could summarize my position, we in industrial marketing, we're looking for what do customers need, mm-hmm. and trying to understand how do we design products for the future. So that's probably the number one most important thing that my group and my department does.
Interesting. So when you're developing products for the future, of course, companies don't know what those things are yet. So part of the marketing need is to try to figure out a way to communicate the future in such a way that your new customer out there is going to understand what that new future could look like, right?
That's right, yeah. So sometimes it's, in order to get a new product like a baseline of a product, we may have to create a prototype and show that prototype to customers and say, because if you go with a blank piece of paper to 100 different manufacturing locations, you're going to get 100 different ideas. So we kind of have to narrow it down to a couple, to a few things that are viable. And so a prototype product we might bring to a customer and say, well, do you like this one? And what do you like about it? What do you not like about it? And a lot of prototypes that we come up with don't ever even end up as products in the end, just because we had a better idea, or we found that there wasn't a lot of interest in that product. So the whole process of product development is there's a lot of starts and stops.
Yes.
And it's just really important to collect that data over time and really study it and really understand what customers want and need.
That's great information, so that when the students are actually developing their ideas into prototypes, and then they have to go out and talk in front of other people about what it is, we would hope they have had enough time to fail a few times to perfect their product, to get to the point where when they get out there, they really they're feeling good about what they created, and they feel as though they are bringing something to their audience that they need. Right. Right.
Yes. If I think the act of going through failure in a safe environment, in a controlled, safe environment, is a good thing. You learn a lot from that. I don't like to always call it failure. Failure. It could just be an idea that never blossomed, or an idea that stopped because you had another idea. There's so many different things we can do with our time every day, and I could have 100 ideas in my, written on a piece of paper, but I only have time for 2 or 3 of them. So a lot of times we have to table those other ideas and try to. But I always try to hold on to any of those ideas so that we're not, so we don't have to, sometimes idea generation, brainstorming, we want to catalog those unblossomed ideas, and maybe we'll come back to them at some point in the future.
So it's a learning process is what we're getting at, right?
Right, yeah.
So, you ended up as a marketing person, but started off as an engineering person. It's an interesting path that you've traveled on. Were there any other, work-related experiences that you had in between?
So it was a gradual shift. Working as an engineer was one thing that I found was I was spending a lot more time with interfacing with my computer. Doing designs, and I really felt like I didn't have that personal connection with people. So it was a pretty quick turn to go from engineering and then to move more into a business role. But what I found was it's really, for me at least, I really enjoy the people aspect and the communication, collaboration with others. That working as a design engineer, you do have that to a point, but what I enjoy about my job now is it's a lot more. There's a lot more communication with others and presenting ideas, explaining concepts to others.
Sounds like you've evolved from when you were younger to where you are now, and you've identified stepping stones to go from one to another, and it's okay to do that in life, right?
Absolutely, yeah. If I'm still changing. I never thought I'd be on a podcast with you. So but I'm not going to be intimidated. I'm not going to say, oh, I can't do that. I might try it and it doesn't work out that well, but that's fine. I'll go back. I'll regroup and I'll figure out how do I do it better next time.
Well, that's a great attitude, and it's great. Hopefully, we can give some of that confidence into the kids too.
Right.
So, how important would you say STEM-based classes for someone interested in, let's say, pursuing a career with your company? How important would something like that be?
It's going to be pretty important, but it's not a be all end all. We have a lot of opportunities for outgoing people who like to be in front of customers to go and sell our product. We actually have a 6-month training program to try to, I'll say, level off some of for those who didn't have the STEM training. We can provide that. We actually have a 6-month training program where we can provide that for them.
Nice.
However, it does help. The more you bring to the table, the better off you're going to be. And it doesn't even have to be formal training. Just something as simple as knowing the difference between a crescent wrench and a pair of pliers. Knowing, if I can tell you a story really quickly, I had one of the first jobs that I had in between as a student, as an engineering student. I was working in this at this company for the summer that made these plastic water, like for a drainage ditch or something. It made the plastic pipes for drainage ditches.
All right.
And I was wrestling with this thing, trying to figure out. They wanted me to pressure test it, and I asked for some help from one of the maintenance guys there, one of the maintenance workers, and I'm sitting there with a screwdriver trying to tighten a bolt. He's like, "Well, son, I'll tell you what your problem is. You don't have to remember my name. You don't have to remember anything about this, but I want you to remember one thing. When you're screwing in a bolt, righty-tighty, lefty-loosey." I was trying to thread it the wrong way. I was going the wrong way. So just some of those simple, being able to work with your hands, little things like that can really go a long way in establishing what you know and then building a platform so that you can build on top of it.
That's great, and thank you for that story, by the way. That's
and I don't remember the guy's name either. Maybe he told me not to remember it, so I subconsciously forgot it.
Well, he sounds like a great guy.
Yeah.
You know, he's willing to help the young buck coming up through the system, right?
That's right.
Well, that's great. All right, thank you for sharing that. How about how would students get hand-on experience to build skills that they may be able to use in their adult lives? Do you have any suggestions? I mean, that was a good story. Is it just go out and, let's say, work on your bicycle and take it apart, or do you have any suggestions on how to get hands-on with some mechanical experience?
Yeah, so definitely look at your opportunities. Maybe you have a space like Invention Land where you can come and where it's more of a formal, controlled environment. But if you don't have that, everybody's got a bike pump in their garage. Everybody's got tools in their garage. I'm not saying, make sure you wear your safety glasses. Make sure make sure you know how to operate the tool. You're not going to get hurt. One time, my daughter, I have 3 children. My daughter, when she was younger, we were spending. It was a summer day, and we were out in the garage. And I was trying to do some work. I can't remember what project I was working on. And she came out and she said, "Well, can I help?" I said, "Yeah, absolutely." So I gave her a DeWalt power drill. The battery was only about 25%, so I knew it didn't have a lot of power to it. But she drilled her name into I had just a piece of plywood or a piece of 1x8, and she drilled her name into the board. And it took her 2 hours. So one of the skills she has now is how to operate a power drill. That's all it takes. You just have to get out. Don't be afraid to pick up a tool, try to use it. Don't be afraid to try 2 different tools and ask yourself, well, which one works better? Does this one work better, or does this one work better? And I also have a lot of spare parts just around my garage, just to try to say, what can I build today? What should I do? How can I fix something in my house without spending any money and trying to make have some fun with it.
That's a good catalyst right there, because things tend to, they do wear out or they do break, and buying new isn't always the answer. It's, can I go out and figure out a way? So not being afraid to take something apart, look at it, using your observational analysis, try to find the broken part, and then how can I repair that? And if you can walk away with it from that experience with not being afraid of tools and building confidence around that, maybe your maker skills will start to grow.
Right. Mm-hmm. Yeah, well said.
Oh, thank you. So let's see here. So knowing what you know today, what advice would you give a person interested in entering your industry today?
So it's a different, that's a great question, George, and it's a different industry today than when I joined way back when. When I joined, there was, you had your mechanical products, you had your electrical products, and where today there's a combination, looking at high volume, looking at the factories that are being created today. There's really a need to understand both the mechanical aspect of a design and the electrical aspect. And oh, by the way, we can collect all this data now and put it on a cloud server. So there's an IT piece of it. There's an IT piece to the equation as well. So my advice would be learn a little bit of something about everything, because it all kind of comes together. Of course, you want to specialize when, if you're going to go to college, you're going to get a degree in something. But try to take a class that you don't know something about. Try to expand your understanding so that you at least know you have a minimum level of understanding across multiple disciplines.
That's great advice. So it's maybe a little bit of coding, maybe a little bit of mechanical, dealing with mechanical devices of some sort. When I was a boy, I used to take things apart, and I had some. My Uncle Bob is what I called him. He's my Cub Scout master, but we used to take stuff apart all the time, and I think it was just such a wonderful experience. He didn't have to explain everything, but what I would see is that he would take things apart, and he'd figure out a way to put them all back together, and learned how to use tools and in many different forms. But your advice would be, with where the world's going today, there's a lot of IT, there's a lot of mechanical still, right? Robotics is really starting to take off, and AI is coming around, right? So how would you say, from the world that we're in today, you have 3 daughters, and are you trying to find a way to give them a little bit of experience in those zones as they're growing up? And if you have you found a unique way to try to get through to them so they kind of get the picture?
Yeah, I try to use day-to-day. There's too many things to teach my children all at once. So I try to pick one thing at a time. And it's, maybe today it's how to check your oil in your car. Maybe tomorrow it's how to change a broken fuse in your car because you honk the horn too much and it burn out the fuse.
Yes.
That's okay. Fuses are inexpensive, but maybe we shouldn't hold the horn down for that long because we know what's going to happen. Maybe that's a symptom of another problem with the car. So just trying to use every day as a learning opportunity to learn a different skill, get a different skill in your toolbox, and just over time, as I'd said before, that you have all that, you have that higher platform. One a quote that I'd like to mention is, as a mechanical engineer, Isaac Newton is Newton's laws of motion. That's kind of like the core, the core scientist who I built a lot of my knowledge around. And he had a saying. I don't think it was his saying. He's just the first famous guy that said it.
Okay.
He said something to the effect of, "If I could see further than other people, it's because I was standing on the shoulders of giants."
Mm-hmm.
So, and what he meant by that was, if you, or at least how I interpret that is if you can be mentored, if you can mentor someone, they're probably going to start at a higher level or a higher understanding of how the world works. And they're going to do better than you did. They're going to, and we see that through all the different technological innovations that are occurring today and the rapid pace of innovation.
That's a wonderful quote. Good, and thank you for that. That's another good story. All right, super. So next question would be, do you believe anyone can be successful? And if so, what do you think some of the most basic building blocks need to be in order to empower our youth?
Yes, I think anyone can be successful. I think confidence is really important. Mm-hmm. Treating others with respect is important. Being able to communicate is important. And it's not just being able to communicate, it's being able to communicate something of value, something that, or an idea or a concept. So absolutely, and I believe anyone can be successful. Maybe today people get perhaps pigeonholed into, well, you can't do this and you can't do this. And my advice to those people is, yeah, you can't. You can. You just have to find a way around that person who made you, who explicitly told you couldn't do it. Or perhaps a lot of times I know with youth, they may feel as if they can't do something. No one ever told them they couldn't. They just feel, well, I can't do that. I'm not good enough. I can't do that. Right. And if, you can. Just don't be afraid. If you go through life, you're going to be stressed out in life. If you go through life stressed about, you can stress out about the little things, like, oh, did I lock my key? Did I leave my keys in my car? Did I forget to do this? Or you can worry about the big things, like, oh, am I going to be late for being on a podcast? So I've chosen to try to be worried about the bigger things. Yes. And then the little things just kind of go away.
That's great advice. Thank you. How about mentors? Did you have any mentors when you were growing up? What giant shoulders were you standing on, John?
Yeah, that's a great question. So, of course, my parents, my grandparents, I had a lot of teachers who I know believed in me and who helped me to really understand abstract concepts or complex things. So as far as mentors, I don't have any one person in particular. It's probably a conglomerate of multiple, different people. There was the guy who taught me righty-tighty, lefty-loosey. Right. He was a mentor. You can learn from anybody. You just have to be able to communicate with them and, let them know, hey, I'm having some trouble here. And in that case, that gentleman, he saw I was having trouble, and good for him. He could have just walked away. He could have done nothing. Maybe I would have figured it out eventually. Maybe I would have thrown down the tools in disgust and quit and not gone into engineering. Yes. But I don't have any one particular mentor, but trying to just being kind and treating others with respect opens the pathways for that positive mentoring communication where you can learn from someone.
Right, and I think as we approach where we're getting a little older, I think it's a part of our responsibility to mentor those who are younger than us the way others mentored us. Right? I mean, I feel good always trying to help our youth to build their confidence, to try new things, experiment until they find a path that's their path. Right? And I like that a lot. So.
Absolutely, I would agree.
How about, do you have any maker tip for today? Like if I was working at SMC or I wanted to work at SMC one day, we call them maker tips or, like basic making. So from the world of understanding how air is moved, maybe through that pneumatics world, is there any maker tip that would be helpful for me to know if I worked at SMC?
So I'm going to deviate a little bit on that question. It's not going to be specific to SMC. I'm going to use a quote that I got from my grandfather. And perhaps other people have heard this already, but I think it's pretty it's a good quote. Measure twice, cut once.
That's a great quote.
Yeah, you can't put, if you cut a piece of wood in half and you cut it too short, it's really hard to put those two pieces back together.
It really is. Grandpa did a good. That was good advice from Grandpa. So I see something on the table here today. Do we want to touch on that a little bit? What's going on?
Yeah. So what I have here is it's a part. This is an end effector for a collaborative robot. So essentially, this is two fingers that can open and close to pick up an object, perhaps move it over here, and then drop an object. So this is designed to interface with a common manufacturer of collaborative robots, and it's using compressed air as the energy source, so it's a pneumatic gripper. And here I have all my communications through this cable, through this electrical cable. So I brought this because now this isn't everything that my company does, but I do think it's pretty inspiring because now I can say I make parts for robots, and that captures people's attention.
Right. And one day you'll be a grandpap, and hey, what's grandpap do? Well, he makes parts for robots. That's just cool.
Enough said, and you just drop the mic. For that.
That's good stuff. Well, what a nice part. So, in other words, I'm on an assembly line, and maybe now I'm not just pushing a box off of the assembly line that has a million parts going by a day. Now we are picking a box up, maybe pulling it off and putting it on another assembly line. So that's what that robotic arm could do for us, right?
Exactly. Yeah. There's think about it, George. All the applications where a person can pick something up and place it now, once it becomes repetitive, we can do that now with a collaborative robot with robots, and it's we're going back to that the first analogy with pushing a box off a conveyor belt. That's kind of brute force, where this has a little more finesse. This is more of a softer touch. There is still I don't know, this particular product wouldn't work well with like a donut. It's going to squish the donut. So you have to think about the force control. But there are products that can do that type of work as well. So where they have different ways to gently pick up an object without crushing it.
So isn't that interesting? Where we have the world of pneumatics, and then inside the world of pneumatics, there are many other little worlds, aren't there? There are,
yeah. There's so many, and there's so many different applications. A lot of times we'll have products that are kind of general purpose that can be used in a variety of applications. But say, for example, this component, this is designed specifically as an end effector for a specific brand of collaborative robots. So it's a very specialized part. But as the industry, as other manufacturers complete their product lines and build up their product lines, our products are continually changing to match up with those other innovations.
Understood. So in the early days, it was your founder as a single person, as an entrepreneur, and here we are all these years later. Are we talking about a couple hundred people who work with the company worldwide, or how large is the organization?
Yeah, so we went from, in 1959, just one person's idea, where today we have over 18,000 employees globally.
Isn't that wonderful?
Yeah, a lot of people.
A lot of people, a lot of jobs, a lot of improvement in people's lives from that one gentleman who decided to venture out there and become an entrepreneur and solve problems.
That's right.
Isn't that wonderful? I had let's kind of move into the future if we could for a minute.
Sure.
So what do you think the next big innovation might be in your industry?
The next big innovation. Well, there's a lot of right now. There's a lot of cables, and one of the products that we had highlighted recently was our wireless communications system. So a lot of times, so I really see wireless and products that can communicate with different industrial Ethernet networks and other communication protocols. So there's a lot of, I'll call it digitalization.
Yes.
So combining a mechanical design with an electrical control system, but making sure that it's done in on a safe protocol with all the machine safety in place. So really, I guess I'll summarize. It's really three things. It's sustainability. How do we make products that consume the least amount of energy that for a given output? It's safety. How do we design products that meet all necessary safety requirements so people are safe during the manufacturing process, and the products that manufacturers are making are safe? And digitalization. How do I send feedback through for this product that we're looking at here? How do I send feedback back through this cable to a programmable logic controller, so I have a digital record of how many times this gripper, how many times it actuated?
Understood.
And we can use that data for predictive analytics. So as an example, if I see a pneumatic actuator and its cycle time used to be 3 seconds and now it's 4 seconds, maybe it's time to change that. Maybe I've got a broken seal. Maybe I've got a leak in the system. So trying to use data, IT analytics, to improve the operation of machines.
That's very interesting. So you can predict when, let's say, a seal is going to go bad and you're going to lose 25% of your efficiency on a production line.
That's right.
And then that leads to additional problems in that system, right? So seeing that you are always running at optimum performance would be the goal, right?
Yeah, it's almost like, in a way, it's almost like you'd mentioned in the beginning about our bodies there's similarities between our bodies. So if my blood pressure is going up, that's a signal I need to do something. I need to exercise more. I need to do something. In a pneumatic system, in a machine, we see those same signals. We just have to be able to measure them and pay attention to them.
Yes.
So if I'm not taking my blood pressure reading when I go to the doctor and I have blood pressure problems, well, it's because I wasn't measuring it. Where in the future of pneumatics, looking at trying to get more of that data, whether it's blood pressure, whether it's pressure, the flow, the cycle time, the position of a part, and keep in mind we have a lot of machines that are produced. We have a lot of data from different machines, so I can have 10 different machines, and I notice that all 9 of them are operating exactly the same within a set of parameters, but machine number 10 is doing something a little wonky. It's doing something different than all the rest. So I can study that data over time and predict in advance. Oh, yeah. Whenever we see it start doing that little thing that it does, it's time to change this part on the machine. So
you get down there with your screwdriver and lefty loosey, and you go through the process of changing that out.
That's right. You remember back to that guy that told you that righty tighty lefty loosey. That's right.
Oh, isn't that fun? You're having sounds like a great career. It sounds like you're happy with your work and you're progressing very nicely. I hope that. Let's see if there's anything else we want to cover here today. Do you have anything you'd like to bring up that you'd like to share with with our youth today? Because you're going to get a direct impact right into them today.
Yeah, just if I can reiterate what I'd said earlier, some of the things I said earlier. Don't be afraid to roll up your sleeves, pick up a tool. Don't be afraid. Don't let others define what you can and can't do, whether it's an explicit something that they actually said to you or the way you internalize what they said. And just don't be afraid to make a mistake, to make a safe mistake.
That's great.
Don't make big mistakes. Those sometimes you can't reverse, but don't be afraid to make little mistakes.
Yeah, that's what prototypes are for, right?
Right.
Kind of forcing you to only go so far and take a look and then reevaluate.
Right.
So Okay, I do have two more questions for you, John. And then, how difficult is it for SMC today to, go out there and hire young adults? Do they have the skill sets that you're really needing today, or are you needing to do a lot of training once you're finding people that have some potential?
I'd say it depends on the individual. There are some people who can come in who may not have. There's some people who come in with the skill set, but perhaps the wrong attitude. There's other people who come in with the right attitude, but the wrong skill set. I'd rather have that one, the wrong skill set, right attitude, because a lot of times we can, with our training program, we can teach them what they need to know. There's a lot of opportunities. The world is different than when I started all those years ago, and I'm sure when you started,
yes,
I won't get into how it's different. It's always different. Every generation I think has different challenges and different opportunities. But I see a lot of positive things happening, and there's just a lot of things for the students of the future.
I think one of the things that really hasn't changed, and I hope it never changes, that the students who are positive and are willing to listen and want to learn, as you're mentioning, that's what you'd rather have, is somebody that is willing to want to grow, right? And I don't think that's ever going away. I think businesses are always going to be in search of our youth that have that kind of mentality. And so this one's a big question for a different kind of an audience out there. But if you could share something with our education leaders here in the United States about how they could better prepare students for the jobs of the future, what would you suggest?
So that's a great question. I would probably suggest that they get involved in the same organizations that people from industry are in. As an example, there's a organization called, it's like a robotics competition, and that's a great opportunity to network, for educators to network with other professionals in the industry. At my company, at SMC, we have several people who act as mentors on these robot competition teams, and just trying to get involved in those types of organizations so they can network so educators can network with professionals,
yes,
and get to know them on a personal level, but also understand what skills are needed for that type of for some of the challenges that we're looking into in the future. And some of those same challenges are given in these robotics competitions.
That's great advice. And folks, that is John Halvorsen. Thank you, John.
Thanks for having me.
Bye now, everybody. Have a great day.
For more information about the innovations and ideas changing tomorrow's world, tune into Tomorrow's World Today, now streaming on Science and Discovery, or visit tomorrowsworldtoday.com.